dx equals 0. And what I suggested here is that you are going to you actually, a better way to do it now that I'm not super tired is to actually take this off to the side here and solve for dy dx like we've been doing. So dy dx ends up being minus 2x over 2y, which is minus x over y, like that. All right, now that's going to be useful because we are going to have to substitute back in, but then we take another derivative on the left here. Okay, it's like the left's really your like flow of your problem. So derivative of 2x is 2 plus, now what we have here is a chain rule derivative. I'm sorry, not a chain rule, product rule. So it's derivative of the first, derivative of 2y is 2 dy dx. Keep the second, which is dy dx, probably a little weird, but that's what it is. Plus, keep the first 2y, take a derivative of the second, d squared y over dx squared. And so I'd have to look up why the 2 goes above the d and the 2 goes above the x, but that is the correct notation here, equals 0. Take a look at that and let me know if anything there is unclear.
How did you get the negative 2x over 2y equals negative x over y?
Okay, so you subtract 2x from both sides.
Oh, okay, yeah, okay. Yeah, that's what I thought. I just wasn't
Yeah,
sure.
it's the same as yesterday. I did skip the step because of that, but yeah, it's the same as yesterday. On the left here is more important, I guess. It's like being comfortable with the idea that that's the second derivative. On the left here is 2 plus 2 dy dx squared plus 2y d squared y over dx squared equals 0, like that.
Okay.
All right, now we because the dy times dy dx times dy dx is dy dx squared, so we're now solving for this right here on the d squared y dx squared. To do that, we're going to subtract. So we'll do that in steps here. 2y d squared y dx squared equals minus 2 times dy dx squared, and then you divide everything by 2y, like that, and then you get d squared y over dx squared equals -1 minus dy dx squared over y, like that. So the twos cancel. You can cancel with each of those, basically. But we're not done. Wait, there's more. You have to substitute in for dy dx, which is why I had you solve for it back up here. So that becomes -1 minus x over y squared over y. And this is probably the most basic question that you can get, the circle here. And we still have more to do to simplify this. Okay, so just keep in mind, these get really, really complicated pretty quickly. So we have to square the top, square the bottom. So this becomes -1 minus x squared over y squared over y. 1 over y, 1 over y, like that. And so this becomes -1 over y minus x squared over y cubed, like that. And then I suppose you could make a common denominator here, making that y cubed on the top on the bottom. To multiply top and bottom by y squared minus y squared minus x squared over y cubed. And then I suppose you could even further go here and say, okay, I'm going to factor out a negative y squared minus plus x squared over y cubed, like that. All of these would be reasonable to have in your answer. In any of these lines, truthfully, like even the one I manipulated up here, even the one up here. This depends on the instructor.
Okay.
What do you think?
Yeah, it looks like a lot of steps.
Yes, it's a lot. It's really a lot. And that was the easy one. That was the one that really.
Right.
I mean, they tend to not give you they don't give you the hard one for the test on the second derivative, but for the first they would.
Right. Um, and we do 53.
Sure. You want to do second derivative on this?
Yeah.
Okay, so the first one here, product rule derivative here is derivative of the first, that's 7, derivative of 7, I'm treating it as 7x times y. So derivative of 7x is 7, keep the second, plus the first times the derivative of y, which is 1 dy dx. Then, sorry, plus the derivative of sine is cosine x equals 0. So what I like to do here is solve this for dy dx, kind of over here off to the right. Make sure we've got it. We need it later. So you're gonna subtract the 7y, you're gonna subtract the cosine x. So you have 7x dy dx equals minus 7y minus cosine x. Divide everything by 7x here. So you have dy dx equals minus 7y minus cosine x over 7x. And we'll come back to that. Now on the left here, it's probably good to rewrite it, without some of the extra stuff here, the ones, or if you can cancel anything. All right, so you got to take a derivative. You got to take a derivative. So derivative of 7y is 7 dy dx plus, now this in the middle here is a product rule again. So it's keep the first, I'm sorry, derivative of the first times the second plus the keep the first, take the derivative of the second, d squared y over dx squared. So there's typically only one d squared y over dx squared.
So whenever we take the derivative of dy over dx, that's what it becomes, is
Yes.
d2y over dx squared. Okay.
Yes, exactly.
Okay.
Okay. So then we take the derivative of cosine, which is minus sine x equals 0.
So that one
And
just
then
flips back and forth then.
say that again.
It just flips back and forth because it started
Yeah.
off as, okay.
Yeah, there's kind of like the derivative of sine is cosine x.
Right.
Derivative of cosine is minus sine x. Derivative of minus sine x is minus cosine x, and then it comes back.
Okay. Yeah.
So like sometimes they ask you for like the d dx, like 105 of sine x, and there's a pattern that you get.
Oh, okay.
All right, so on the left, so these combine, I mean, this is 14 dy dx.
Right.
And so we can move that over to the other side. You can move over the sine x here to the other side. So it's 7x d squared y over dx squared equals sine x minus 14 dy dx. And then you can divide everything by 7x. So your second derivative, d squared y over dx squared equals, well, just copy this down. And then again, you gotta substitute in for dy dx. dy dx is this mess up here. So it looks bad, and it is. I mean, it's that's dy dx. There's sine x I mean, things do cancel, but like this is really bad. But let's, spend a little bit of time here soon. So this 14 here, it's going to cancel with the 7. So you're going to have just a 2 out in front. So we'll distribute the negative into the top. So it's sine x. The minus 14 is really a minus 2. So plus 14y plus 2 cosine x all over x. And then it's all over 7x. So you multiply by 1 over 7x, top and bottom. So this becomes, and all this is just algebra. It's just manipulation of the equation. So it's sine x over 7x plus 14y over 7x squared plus 2 cosine x over 7x squared. And so you could make a common denominator here of where we multiply the top and bottom on the left by x. I mean, in some ways it feels like you're just going backwards, but it's x sine x plus 14y plus 2 cosine x all over 7x squared.
Okay, yeah. Okay. We can move on to the next chapter. So the ones that I sent you yesterday.
Okay, let's take a look here and see what you sent.
Yeah, it's like finding the derivative with the limit process.
All right, so this is odd. Like we did this. I mean, we did this. Like this is like from 2 sections, or I don't know. This is like the definition of the derivative.
Oh, okay.
But we can do it. I mean, I'll show you. Which one do you want us to do?
This is number 3.
Number 3. Yeah. Okay. And this will not be on your test because there's almost no way to make this multiple choice.
Right.
Okay, so it's the limit as h goes to 0, f of x plus h minus f of x all over h. So f of x plus h is x plus h cubed minus 2 times x plus h plus 1. So unfortunately, I have to expand this awfulness. So if you recall, it's x plus h times x plus h times x plus h, like that. And you end up getting x squared plus 2xh plus h squared times x plus h. Okay. So we have to expand that. The middle one becomes minus 2x minus 2h plus 1. All right. And so you really do want to multiply this out. I'm going to just use a calculator though.
That's fine.
If I can get one here real quick to open up. Yeah, sorry. Taking a little longer here. All right, so it ends up being x cubed plus 3x squared h plus 3xh squared plus h cubed minus 2x minus 2h plus 1. So everything we just wrote is the f of x plus h. That's everything that goes there. So you write the limit as h goes to 0,
Right.
and you grab all this stuff, which benefit of Zoom is I can copy minus f of x, so minus the original, which is x cubed minus 2x plus 1. Okay, and keep in mind the whole while here that if you put 0 in for h, you get division by 0, which you can't do.
Yeah.
Okay, so as a result, that means that, well, you have to keep doing something until you get rid of the division by 0. All right, is that okay for right now?
Yep.
Cool. So the next thing here is to subtract out. This becomes Let me do it in red. Blue. Minus x cubed minus 2x minus 1. Okay. And then you do this. Subtract, 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 subtract like that. And then everything that's left has an h in it. So you're dividing everything by the h, but let me show it here. 3x squared h plus 3xh squared plus h cubed minus 2h all over h. So you divide each term by h, and you get the limit as h goes to 0, 3x squared plus 3xh plus h squared minus 2. And now, because there's no more division by h, you can put 0 in for h. So this becomes 3x squared plus 3x times 0 plus 0 squared minus 2. So 3x squared minus 2 is your answer.
And then would we take the derivative of that?
No,
For-
this is the derivative. This is the
Oh,
derivative.
oh, it is. Okay.
Yeah, and that's what's maybe hard to realize is that, the derivative is, when you do the limiting process, that is the derivative.
Oh, okay. So it's not like any extra. Okay.
Yeah.
Let's see.
Now, I think there might be a bit more, like there might be a whole like, okay, we need to uh, um, yeah, did it say to evaluate? I don't know.
Let me look. I may have sent you the wrong chapters, actually. I'm not gonna lie. Because I'm looking at the exercises for this chapter, and that's not the right one.
Yeah, I mean, this looks, I mean, it says 2.6. I don't know if that
It does? But then where is that from? Hold on, just a second.
I mean, this happens from time to time, you just,
2.6 exercises. What? Oh yeah, it's because it's the yeah, okay. I sent you the ones for the review exercises, that's why. Okay. Um, Can I send you some now and then
sure, yeah, of course. Of course.
okay. Because I was gonna say I think I sent the wrong ones. Okay. Okay, I just sent them.
When is your exam?
Saturday.
Saturday, okay. All right, so see, you sent a couple of pictures here. Get those uploaded. Just waiting for those to upload. All right, got them. Which ones do you want us to look up? Number 3 again?
Yeah, oh yeah, like one or well, you can't see number 3, so number 2,
Number
which is
2? Okay.
Yeah.
All right.
or no, it is number 3. I don't know why.
It's a little bit formatted awkwardly. Yeah, so this is related rates, and this is kind of the next
Yeah.
thing that you're doing here. So okay, so dy dt is this is, I mean, this is what's this? If you let me rewrite this as x to the 1/2 for the moment. Now if you just normally take a derivative, you're normally taking a derivative dy dx. Okay. dy dx is 1/2 x to the minus 1/2 power. Is that okay so far? If you just
Yeah.
take the derivative of this, okay. Now dy dx equals 1/2 x to the minus 1/2 power. Well, x is really a function of t now. So you have to take a derivative of x with respect to t. So what that looks like here is you end up multiplying by dx dt. So on the left, it just becomes dy dt. So dy dt equals 1/2 x to the minus 1/2 power dx dt. So it's like y is a function of x, but x is a function of t, so you have to take a derivative of everything there.
Okay. So do we just show how it like changes into
Well, there's more to do. I guess I don't think I did a great job of explaining this, but that is the mechanics here of it. It's like it's like now whenever you take a derivative with respect to x, you add a dx dt. Just
Okay.
like in the implicit derivatives, you added a dy dx.
Yeah. Okay.
So what this means is you have to evaluate the function at x and then multiply by dx dt. So for part A dy dt equals 1/2 4 to the minus 1/2 because x equals 4, and then dx dt equals 3, like that. Okay, so this becomes 3/2. 3 times 1/2 is 3/2, and this is 1 over the square root of 4, which is 2. 3/2 times 1/2 is 3/4, and that's your final answer.
Okay.
And that's what they're looking for. They're gonna ask you for something like that.
Okay. And then
Part
can
B
we
is a little bit more difficult. Part B, you're still reusing this line up here, but this time they're asking you to solve for dx dt. You might be thinking, well, I already have dx dt. Well, they made you had it for the previous problems. They want dx dt. That's what they're solving for. They're giving you the x value. They're giving you dy dt. They're saying dy dt is 2. X is 25. Dx dt like this.
Okay.
So this becomes 4 equals because you multiply both sides by 2 to get rid of the 1/2. 1 over the square root of 25 dx dt like this. So then this is 1/5, 4 equals 1/5 dx dt. Multiply by 5. So dx dt equals 20.
Can you scroll up a little more? I just want
Sure.
to see the work again.
Sure. For this one or for the previous one?
No, for this one. So you just. Oh, so then we're solving for dy dt or dx dt this time rather than,
Rather than dy dt.
okay.
And they could, I mean, the other variation of the problem is they could give you dy dt and dx dt and you have to solve for x.
X. Okay, so you're just basically like you find out what you're using and then you just substitute everything in.
Yeah, exactly.
Okay.
Exactly. So the next thing, sort of a comment here is that you're going to use these related rates in word problems, story problems, application problems. So you really want to get solid on these. Like these are worth spending a little extra time learning because you end up using them in the next section.
Yeah, we have some story problems here. I can send because we should look at like maybe like one or two.
Sure. There's a bunch you'll get. So I've got 7 and 8 on my screen as well if we want to do any of those, but it's
Yeah,
up to you.
I'm just gonna send these over also real quick. Okay, we can get started on those. I'll send these over.
Okay. All right, did get those. They're uploading now. Just be a minute or two to get those going. And keep in mind, like they can't ask you all application problems. I mean, you're gonna get some of everything, but I would expect to get a couple.
Right. Did you get 7 and 8 too?
Yes.
Oh, okay.
Where do you want us to go from here? 7, 8, something
Yeah,
else?
7.
Okay. Um, so for 7, probably doesn't apply because it's multiple choice, but the units do matter. In other
Okay.
courses, they really emphasize that, but I don't think, I mean, could be. I mean, you would have like all the same answers, but with different units. And I guess, so that's something maybe to look at the lectures and see if that's been I don't know if this or not.
Well, or he could post the same answer, but with different units or something.
Exactly. Yeah. And I mean, there's a statistics professor at Arizona State University that does that, which is quite difficult for students, but I mean, it's not that difficult, but it's like it's another thing to like have to deal with when you're doing this. So it's just because it's the way it is. So,
Right.
so like instead of writing dy dx, I'm going to write now dy dt.
Okay.
And again, dy dt really is dy dx times dx dt.
Okay.
So you just kind of shortcut that. So it's 4x, but whenever you see an x, just like with implicit derivatives, you get a dx dt. Plus derivative 1 is 0.
Okay.
Is that okay
Yes.
so far? All right. So the um the dy dt equals 4. Okay, so we're solving for, yeah. So we're trying to, so part A is now x equals -1. So dy dt becomes 4 times -1 times 2, which is -8 centimeters per second.
Okay. So it's the same, you're just
Yeah,
substituting.
B is the same. You're just putting 0 in. So dy dt equals 4 times 0 times 2, which is 0 centimeters per second. The derivatives are all rates, and that's why it's per second or per something.
Okay,
Usually it's per unit time.
okay. And then can we do 8?
Sure.
And we don't have to do all of them, we could just do A.
Okay. Yeah, so a couple ways to do the derivative here. One option is to use quotient rule. It's kind of what most students veer towards on this because it's got a top and a bottom. You know, you make F1 and G1 plus X squared, and that does work. The other option here is a rewrite. Let me do that for you here, is that y equals 1 plus X squared to the -1 power.
Yeah.
And then from here, it's actually a power rule followed by a chain rule. Now, it doesn't matter to me. Which way do you see it, or which way do you want me to work through it?
Can we do both ways?
Sure. So quotient rule, F prime is 0, G prime is 2x. So your derivative, y prime is 1 plus x squared times 0. And so that's where there's this kind of the shortcut over because this goes away.
Right.
Minus 1 times 2x over 1 plus x squared squared. So it becomes minus 2x over 1 plus x squared squared. All right, so that's the first way. Second way is to treat this as y equals u to the -1 power and u equals 1 plus x squared. So the reason is it's a chain rule problem. So you know how to take the derivative of u to the -1 or x to the -1. The derivative is -1 u to the -2 power, but you have to multiply by u prime. Does that look familiar to you?
Yeah.
Okay. So this becomes -1 over u squared times u prime. Well, what's u prime? Well, it's 2x. Now we start substituting in for u prime, 2x, and for u squared, it's 1 plus x squared. So it becomes -2x over 1 plus x squared squared.
Okay. Perfect. Mm. And then did those problems upload for you?
Good question. Yeah, they did.
Okay.
Yes. So just from here, I mean, just to close out this problem, you said part A, you would put, and then I'm sorry, I did
Oh,
mess
no,
up here. Yeah, you got to add in a dx dt at the end.
okay.
So, it's kind of like you either do it as part of it or you just make sure at the end you've got a dx dt, but they
Yeah.
give you the same result. Okay, and then so -2 is your x value. You put that in, or you put those numbers in and you got it. All
Okay.
right. Yes, they did upload. Um, right, we got 23, jump to 25, 31, 37. These are all the difficult ones. Where are the like cone or sphere or circle?
Let me look, because those are the ones he put on the suggested homework, but I can look for the.
I mean, those are the better ones to start out with.
Okay.
A cube, something much more basic than this.
Okay. Um, okay. I sent 2 over right now.
Okay. Just waiting on those. There's a meme about the internet being slow. All right, upload. Right. Almost there. Okay. Yeah, so 11 is good to do, 13 is good to do. I mean, these are just my recommendations, but where would you like us to start?
We can start with 11.
Okay. All right, so this is where most students say something like, are you going to give us the formulas for insert whatever, this case, yeah. So these are all geometric shapes. I'm going to drop in the chat. I found a really good reference sheet that is got, everything you would need for it's usually for geometry students, but and I mean some of these, so the area of a circle is pi r squared. Okay.
Okay.
And you have to think of this as a as a function of r, just like when you write y equal 5x squared, what that really means is y is a function of x. So if you really don't like the r, the fact that it's not x, you can change it. You can make it x squared, that's fine. Okay. Now when you take a derivative here, you're taking a derivative, and so what I typically do is switch to notation like this. I switch to just a prime, which is really dA dt.
Okay.
If you don't like that, and that's totally reasonable if you don't, what we're doing is dA dr times dr dt. But it's always a derivative of the thing with respect to time is what you're getting to. The dy dt, in this case dA dt,
Okay.
equals now pi. Now the derivative of r squared is 2r, but then you have to give a dr dt in there like that.
Okay.
So, summarize here on the left, it's dA dt equals 2 pi r dr dt. And we go back to the given information. So I didn't read this, but so and what students really struggle with is trying to figure out, well, what's what, okay? So it says the radius r of a circle is increasing at a rate of 4 centimeters per minute. That is dr dt.
Okay, yeah, that's
And
what
you
I,
know that, and you know that because of the units.
yeah,
And then they're actually giving you the value of r. Okay, so now you have the information. It's good to identify it as you go. dA dt equals 2 pi 37 times 4.
okay, yeah,
So then you multiply that out with keeping the pi. It's like that, and then you get 296 pi. Now the units here, you really want to go back to this. Like, so what is A? A is area. So that's centimeters squared per. You really go back to whatever this is to get the right units. This area is in terms of centimeters squared. P is the time. That's the per minute.
oh, okay, yeah. Yeah, okay, yeah, that makes sense.
All right.
And then can we do 13?
Sure. All right, so the volume of a sphere is increasing at a rate of 3 inches per minute. So that's r prime. That's dr dt. The radius with respect to time is 3. Okay, so a sphere, you got volume of a sphere formula is 4/3 pi r cubed. Oh, so you mentioned you get like a cheat sheet thing you can bring to the
Yeah.
test. I mean, I
Yeah.
would probably throw on a few of the formulas from there,
Okay.
just so you don't forget.
Yeah,
Um, so the derivative here, dv dt, derivative volume with respect to time is 4/3 pi. Bring the 3 down, r squared dr dt. Okay, so the 3 cancels the 3 on the bottom. dv dt equals 4 pi r squared dr dt. Now, side note here, 4 pi r squared happens to be the surface area of a sphere, which is always the case. The derivative of the volume is the surface area.
okay.
So when students taking pre-calculus, I wish I could tell them, or trigonometry or something, geometry, it's just say, well, you actually don't need to memorize them because you just take the derivative of the volume, but they don't know, it's unknown. So they're giving you, in this problem, they're giving you radius is 9. So r equals 9, 4 pi 9 squared times 4. No, 3. 3. That you gotta do it again for 4 pi 36 squared times 3, because they're asking for it at two different radiuses.
Right.
Yeah, two different radiuses. So you get those numbers here. I mean, this to me is the more of the classic exam question. There are questions like the ones you did send. There's usually a triangle or ladder problem or other things. So I don't know. We probably ought to pick up on those tomorrow.
Yeah, that's fine.
And
Yeah,
then let me just get these last two numbers in. But and sometimes the answer doesn't mean anything. It's like, what does this even mean? Like, I don't know. I mean, we know the units. It's the units are inches cubed per minute. I mean, what does that even mean? I mean, it's like a science fiction movie where, something is growing super fast, I guess, but.
right.
Okay, we'll go ahead and stop here for today.